In last video, we discussed about some of the physical properties of solvents like melting and boiling point, heat of fusion and vaporization, as well as dipole moment. Now in this video, we are going to discuss some other physical properties of solvents like dielectric constant and viscosity. Now what is dielectric constant? Actually, dielectric constant, it is correlated with the dipole moment of the solvent and hence polarity. The higher the dipole moment, higher is the dielectric constant. So here ammonia with dipole moment 1.46 dBi unit has a dielectric constant of 22 at 241 Kelvin. Similarly, sulfur dioxide has a dipole moment of 1.61 and dielectric constant 17.27. Water dipole moment is 1.84. Its dielectric constant is 78.5. Hydrogen fluoride dipole moment is 1.9. Its dielectric constant is 83.6. Hydrogen cyanide has a high dipole moment, that is 2.93, and dielectric constant is also high, 106.8. So hydrogen cyanide is the most polar solvent. Dinitrogen tetroxide has a dielectric constant of 2.42 and acetic acid has a dielectric constant of 6.15. So greater the dielectric constant, greater is the polarity of solvent. And the force of attraction between ions, it is given by the formula F is equal to Q1 Q2 upon ER square, where Q1 and Q2 are the charges on the two ions, R is the distance between two centers of charges, and E is a dielectric constant. And from this formula it is clear that dielectric constant E, it is inversely proportional to force of attraction between the ions. It means greater the dielectric constant, lesser is the force of attraction between ions. It means ions will be separated in the solvent, and therefore as soon as ions are separated or dissociated, there is a solvation of ions with the solvent, and as solvation increases or solvation energy is more, it exceeds the lattice enthalpy, and total result of this is the resulting ionic compound, it will soluble in the solvent. And higher the dielectric constant of solvent, weaker is the force of attraction between two ions of the solid molecules, and solvents with higher dielectric constants are suitable to dissolve ionic compounds by means of solvation, and the ionic solute easily dissolves in a solvent when heat of solvation exceeds the lattice enthalpy of solute. This is already I told. So because of high dielectric constant, the ions are separated easily. As soon as they are separated, there is a solvation of ions, and greater the solvation energy, greater is the possibility of dissolution of that particular solute in the solvent. Okay, because this heat of solvation exceeds the lattice enthalpy. Now next physical property of solvent, this is the viscosity of solvent. Now viscosity, it is a measure of resistance to flow of liquid, one liquid over the other, or resistance to flow the one liquid layer on the surface of other. Okay, it is the direct measure of the molecular attraction within the fluid itself, and highly viscous fluids are strongly attracted to their own molecules and they resist the separation. Now, viscosity of solvent affect the rate of reaction, electrical conductivity of the ions, solute ions in the solvent, and especially low or medium viscous solvents favors the processes like precipitation, crystallization, filtration. So viscosity not only alters the rate of chemical reaction, viscosity of solvent, but also some physical properties like, or physical processes like filtration, it is also greatly affected by viscosity. So more viscous liquids, if solvents are there, more viscous solvents, then filtration will be slow. Okay, it will take time. So in this way, viscosity of solvent plays important role. Now next section, chemical properties of the solvents. And the first important property is acidic and basic characteristics of solvents. Now according to Bronsted and Lowry concept, acid is a proton donor and base is a proton acceptor. On the basis of Lewis concept, acid is a electron pair acceptor and base is a electron pair donor. On the other hand, according to this Usanovich concept, acid is any chemical species which is capable of giving up a cation, or the species accepts anion or electrons, and a species neutralizes a base to give a salt. This is called as acid. Or according to this Ansanovich concept, a base is any chemical species that reacts with acid to give a salt, which accepts cations or gives up anions or electrons. And this Usanovich concept, it is the most general concept. On the basis of this concept, almost all the reactions are considered as a acid-base reactions. Now consider the general reaction, that is acid HA reacts with B base, probably this is the solvent, most probably. So when acid it is mixed with basic solvent, then acid donates proton according to this Lowry-Bronsted concept, base accepts proton, and therefore there is a formation of BH plus A minus. Now the proton donating capacity, that is strength of an acid HA, it can be measured by considering a reference base B, which is generally a solvent. Now the value of equilibrium constant K for this reaction can be written as K is equal to concentration of A minus into concentration of B plus upon concentration of HA into concentration of B. Now here B is a solvent, and this solvent is present in large excess as compared to solute. But by rearranging terms, we can write Kb, this concentration of B, it will shift to the left side. So K into concentration of B equal to concentration of A minus into concentration of B plus upon concentration of HA. And this term, it is nothing but the K, that is the dissociation constant or equilibrium constant of acid A, and it is nothing but K into concentration of B. It means if a solvent is present in large excess, its molar concentration does not change, and therefore value of K will be constant, and it is called proton dissociation constant of an acid HA. If the reference base solvent, basic solvent, is very good proton acceptor for different acids, then the extent of proton transfer, it may be 100%. This means the acids are completely dissociated and they appear to be equally strong in that particular solvent. And if proton transfer from two different acid is 100%, the K values for these two acids or different acids will be the same in the solvent taken, and such a solvent in which the two or more acids completely transfer their proton, giving only one protonated species, it is called the leveling solvent for the acids. Leveling solvent for the acids. So for all strong acids such as perchloric acid, hydroiodic acid, hydrobromic acid, hydrochloric acid, nitric acid, they have equal strength in aqueous solution, since they all react completely with water to produce hydronium ion, that is H+. For example, HX, that is acid, stronger than water, reacts with water, and there is a formation of H3O plus X. Now here the strength or the strength of protonic acid depends on the solvent in which it is dissolved. So these are the various acids: HClO4, HI, HBr, HCl, HNO3. When they are dissolved in water, all they produce H3O plus with same concentration, and therefore they are leveled. So water is a leveling solvent for these strong acids, and they form equal concentration of H3O plus. This is very important. Okay, so acids stronger than H plus are leveled to the strength of H3O plus in aqueous solvent. This is very important. So in all these cases, as I said, hydronium ion, that is H3O plus, is left in aqueous solution. Okay, the concentration of which is the same for all these acids. So in other words, all these acids brought to the same level of acid strength, and hence water is a leveling solvent for these acids. Now this phenomena, due to which the leveling solvent makes all the acids behave equally strong, it is called as leveling effect of the solvent. And due to this leveling effect, the relative strength of all these acids cannot be distinguished or measured in aqueous solution. All these acids gets leveled. Okay, for example, when HCl is added in water, HCl forms H3O plus. Okay, H3O plus and Cl minus. So HCl, it is converted into hydronium ion. Similarly, perchloric acid, when added in water, it forms H3O plus. Nitric acid, when added in water, it forms H3O plus plus NO3 minus. Hydrogen bromide, when added in water, it forms H3O plus plus Br minus. So HCl, HClO4, HNO3, HBr, these are the stronger acids, okay, than water, and all these are leveled. They form equal strength of H3O plus, and therefore we cannot distinguish the strength of these acids in the water, and therefore water is leveling solvent for these highly stronger acids. Okay, so this is what is the meaning of leveling effect. So in this video we are discussing about the acidic and basic characters of solvent, and here we discussed what is the leveling effect. So next part of this acid base properties or characteristics of solvent will continue in next video.